Okay, so this video is on tracing questions. Tracing questions are a significant feature on the GCSE. They become a lot more common at A level. It's also a superpower because whenever you look over a student's shoulder and identify why there is a logic error, generally the issue we trace for logic, what you're doing is tracing. You're comparing your mental model of the correct answer with what you're seeing in front of you. Tracing is also a nice word because it also helps us talk about how we use our eyes, because really tracing is about making sure that you are looking at the right thing. So generally in a tracing question, and this tracing question is horribly laid out because the algorithm is given here and the trace table is on the next page. Now this is not a good setup. However, it does give us a clue, and the clue is that maybe if we know what type of sort it is, maybe we will not need to even do any tracing. But we're not going to necessarily be able to jump to that conclusion straight away. And so what I am probably need to do is change the way my page is laid out. Now I have two screens here. Let me see if I zoom out, I can put two on one page. It doesn't seem like I can. If you can have the algorithm on one page and then this the trace table on another page, then that is worth doing. The way this would work if you were in an actual exam is that this would be on the left hand open page and this would be on the right hand open page, so they'd both be visible to you at the same time. And you can see that by noting that this is odd and that this is even, because this is the first on the left and that this is the second on the right. However, in this digital format, it's a little bit of a pain. And so we may need to just use our imagination a little bit. Okay, so let's dive into it and pretend like we don't have these problems. We know what we're going to be looking at. We're going to be looking at the values of array, swaps made, I and T. And so it's worth finding those in the program to get started. So we found array here. We found, and what we're going to do is we're going to just underline the variables first, and that will allow our eyes to trace nicely. Anything that's been underlined is a variable, so I count 4 variables there. Is that enough? Have a look back at the trace table. Yes, it is. R, swaps made, I and T. I also need to identify the opening and closing of blocks, and I'm going to use blue for that. So while opens here and then ends here. And then there's an inner loop as well, and that is going to open here and end here, and then there's a nested if as well, and that is going to open here. Whoops, I need a different color. That is going to open here and it's going to end here. Now note, it didn't have to be this neat. It didn't have to be that the if is inside the while, which is inside the while. You have to look quite carefully at the lines of indentation to see that it is the if is the innermost one, and that first while is the outermost one. It's very important. Generally in GCSE, they're not going to try and trick you on something like this, but it's not impossible. Okay, so this inner context is going to be quite important. So, okay, what happens? Well, we're now going to trace it as the computer would see it. So variable gets assigned, while swaps made is false. And here I'm just going to use my human ability to have a look at where swaps made is set. So it's set here, and it's set, the arrow is a bit confusing actually, because of the assignment notation. It's set, what could we use instead of an arrow? I'm just going to use a little star. It's set here and it's set here. So it's going to be the situation in which this line number 4 doesn't get changed again, because it gets changed to true, which will break the outer loop, but only if it gets to the end while being true. So if this inner loop runs, no, if the inner loop, if the decision in the inner loop is true, and then we're going to continue in the loop. If it's not, then we're not. Okay, well, what is going to happen? Well, we are going to set the outer loop I equals 0, and then and we'll increment it a bit later on. And then if, now here's an important thing to be able to read. Don't think about these. Don't think about I plus 1 as just an incremented variable. Think about it. I plus 1 is on the right. I plus 1 is on the right, and I is on the left. When they're sitting next to each other in the list, I is on the left and I plus 1 is on the right. So what this line here says, what line number 7 actually says, is if the right-hand value is less than the left-hand value, then do something. And that something which is going to follow is actually a swap. And you know that because it says swaps, and you also you can also recognize the pattern that 8, 9, and 10 show you, which is a swap pattern. So it basically says if the thing on the right is smaller than the thing on the left, swap them. Well, what are we doing then? Well, we're sorting a list, and actually we were told that we're sorting a list in the question. So this is bubble sort, and what you could do from here is grind it out and look at every single different permutation. Or what you could do is cash in your code comprehension skills and just do bubble sort. So I'm just going to do bubble sort because I don't have the working memory to fill this in. So I will need to look at the code occasionally to do I and T, but I will be able to do bubble sort on these numbers in the array here. So so let's just set the context. So this is the array. Swaps made is false, and they've already put that in for us. Okay. So swaps made is false here, but the second we start the loop, we switch it to true. So we're probably going to want to set a new context like this. This is the first outer loop. Then I get set to 0, and T is going to get set in the inner loop. So but only if we trigger the decision. So if 4 and 1 are out of order, and what I mean by out of order is that they're not ascending. If 4 and 1 are out of order, then we're going to set the value of T to be the left-hand one, and then we're going to do the swap. So if 4 and 1 are out of order, then T will now hold the value of, this is why it's good to have it on the same page, T will now hold the value of the left-hand one. And let's keep our colors consistent. So will be 4. We need that as a place to hold the 4 while we do the swap. So what we're going to do next is, and I said I wasn't going to need the code, but I actually do need the code because I need to see, yes, they're copying the right-hand one into the left-hand one. And then they're setting the right-hand one by T. So we're copying the right-hand one into the left-hand one. So 1 goes in there. And then T is going into the right-hand one, 4. This one is staying unchanged. And because we triggered the decision, this goes back to false. We're still in the inner loop at the moment. So we don't, sorry, in the inner loop, I does get changed. So I goes to 1. And we have made it back to the beginning. Okay, so so we have arrived back at the beginning of the inner loop, and we're going to repeat what we just did with I equals 1. So now, whereas before we were looking at these two, now we're looking at these two. So we're going to just do the same thing. So are these in order? Well, this one's going to be a slightly quicker one because these ones are already in order. So there won't actually be any changes here. T will be set. So T was set to the left-hand one, but actually the left-hand one's the same this time, so that won't change. And then there won't be any other changes in this loop. So we will be able to escape the while loop when I becomes 2 and the loop breaks. Okay, so we've dealt with the first we've dealt with what we would call the first pass in a bubble sort. And again, rather than trace anymore, using your code comprehension, you can identify that this list is already in order, which means that the next pass, we're not expecting the array to change. So let's move on to the final pass, or the next pass, which we know will be the final pass, and we know that there won't be any changes. So we're back at the beginning, and swaps made has been set to true again. And we don't need to change. If something stays the same, we don't need to refill in the same value. Notice that I'm leaving blanks. That's fine. So swaps made set to true. I get set to 0 again because that's what needs to happen to set the while loop up again. T will get set regardless to the left-hand value. So in this case, the left-hand value is 1 again. And don't worry if this is mystical. I've done a lot of tracing, and after you do enough tracing, it doesn't feel like programming anymore. It's more like doing a Sudoku or a crossword. It's just about seeing what stays the same and what changes. So we are then going to we will set no, I've made a mistake. And we should, you've probably seen the mistake already. T will never actually happen again, because T only happens if the two values are out of order. But that will never happen again because the array is back in order. So actually, the if will never trigger, and all that will change for the rest of this program is I will go back up once and twice. And that is the end of the tracing program. Now, certainly tracing is quite overwhelming when you first see it, but there are only maybe 3 or 4 different traces. And once you've seen them all, you'll just start looking for the patterns. You're not even really thinking anymore. You do have to be able to go line by line, but actually the key skill is pattern recognition. So some crucial patterns that you've got to spot. Variables, notice that I mark the variables in a single color with an underline. Blocks, notice that I mark the blocks with a single color in circles. Increments and kind of little sub-programs like the swap. And then just keeping an eye on where different things are. And then the final trick, the most important trick, is using code comprehension to reduce some of the cognitive load. So a lot of the cognitive load from this comes from the nested loops. But actually, if I know that I'm sorting, then I can take away quite a lot of that cognitive load by always keeping an eye on which bits of the list are in order and which bits aren't in order. The reason they've only given us 3 items is because there could only have ever been 2 passes. So this is definitely the hardest of the ideas we've come across so far, but with enough practice, a lot of the problems go away. In the notes underneath this video, I'm going to make sure to include lots of examples of trace tables so that you can do lots of practice and then just compare them with the answers. There's no real magic bullet with this other than use color coordination and kind of symbols to break up the page, and do lots of practice. Okay, in the next video, we'll look at knowledge questions.